So then finally 2017 I thought we'd have a look at. Now I know we've done this one before, but I think it was ages ago we did this. But 2017, some of the blue pigment azurite was used by an artist in a picture painted in 1600. And it's changed over the years into green malachite. So azurite, the blue pigment, is changed into a green pigment, according to that balanced chemical equation. Analysis shows that the only copper-containing pigment in the painting are azurite and malachite, and that the picture now contains 3.81 grams of copper. What mass of pure azurite contains 3.81 grams of copper? So look at your azurite. The azurite is Cu3, CO3 twice, OH twice. So that's your azurite. Now then, it says, what mass of azurite contains 3.81 grams of copper? So if you look at the azurite, what's it actually made up of? Well, for 1 mole of azurite, you've got 3 moles of copper, so 3 moles of Cu. You've got 2 moles of CO3, and you have 2 moles of OHs. Okay, so 3. From 1 mole of azurite, you have 3 moles of copper. So it says, what mass of azurite contains 3.81 grams of copper? Okay, so 3 moles comes from 1 mole. So 3 moles of copper comes from 1 mole of azurite. So if you've got 3.81 grams of copper, let's convert that to moles. So 1 mole of copper comes from 1/3 of a mole of azurite. If you have 3.81 grams of copper, let's convert that to moles. We'll divide it by copper is 63.5, and when you do that, you get 0.06 moles. So 0.06 moles of azurite will produce comes from 0.06 moles of copper comes from 1/3 of that of azurite. So when you divide the 0.06 by 3, that gives you 0.02 moles of azurite. What mass of azurite? Let's convert this to mass. I will now multiply this by the relative molecular mass of azurite. Again, be careful with those relative molecular masses. So we've got 3 coppers, which is going to be 3 63.5s, plus 2 carbons and 3 16s for oxygen, so be careful there. And we then have 2 oxygen plus hydrogen is 17s, and when you add all of that up, you're going to get 344.5. So be really careful with the relative molecular masses, they tend to be nasty. And when we multiply that by 344.5, we end up with 6.89 grams of azurite. So 6.89 grams of azurite will give you, or will contain, or will produce 3.81 grams of copper. Okay, that's the first part. Now calculate the maximum mass of malachite that will eventually be formed from this mass of azurite. Okay, so the second part of the question. 2 moles of azurite will produce 3 moles of malachite. And it says, calculate the maximum mass of malachite that will be formed from this mass of azurite. So this mass of azurite, 6.89 grams, is actually 0.02 moles. So 1 mole of azurite will produce 3/2 moles of malachite. Now, how many moles of azurite do we have? We've got 0.02 moles of azurite. We've already found that. So 0.02 moles of azurite will give me 3/2 times that, which will of course be 0.03 moles of malachite. And the question says, calculate the maximum mass of malachite. So now I have to multiply that by its relative molecular mass. Again, be really careful. Look at that, it's quite an extensive molecular formula. So 2 coppers is 2 63.5s plus carbon is 12, 3 oxygens are 3 16s, plus 2 16 plus 1 is 17. And when I add all of that up, I'll get 221. So when you multiply 221 by 0.03, that will give you 6.63 grams of malachite. So you'd be really careful now with the relative molecular masses. Then it says, what is the volume measured at STP of carbon dioxide that would be released from the painting in the formation of this mass of malachite? Okay, so if we're forming that much malachite, it's coming from the 0.02 moles of azurite. So come back to your equation again, and what's it telling me? It's telling me 2 moles of azurite will produce 1 mole of carbon dioxide. And I'm asked for the volume at STP. And now it's a gas, right? So carbon dioxide is a gas. And volume at STP, I'm going to use a 22.4 link. So convert this to volume eventually at STP. Okay, so 1 mole of azurite will give me a half a mole of carbon dioxide. I know I have 0.02 moles of azurite, so 0.02 moles of azurite will give me half of that, which is 0.01 moles of carbon dioxide. Now I'm going to convert that to volume by multiplying it by 22.4, and I'll get 0.224 litres. Be careful in case she wants it in terms of centimetres cubed or litres. She's not being specific here, so I can leave it with litre at that, or I could say it's 224 centimetres cubed, either or. And the last bit says, suggest a way that further deterioration of the painting by this chemical reaction could be prevented or delayed. So look at this chemical reaction. We're getting azurite plus water turned into malachite plus carbon dioxide. So this azurite is being broken down by water, as you can see. So if you want to suggest a way of preventing further deterioration, so we want to prevent further deterioration, keep the water away from it. So either make sure that you have it in a watertight, airtight container or dry area. Don't let water get to it. Cover it with a varnish, a waterproof varnish or something, but just keep water away. So keep water away. Suggestions that year were maybe a waterproof varnish, cover it with a waterproof varnish, or just make sure you have a desiccator near it, something that's going to absorb water. Make sure water doesn't get to it.